Yes, we can see that.
I am Randolph West. I am an employee of Microsoft. I work on the docs team for SQL Docs, or database docs, really. And I am the content lead for the Linux SQL Server documentation. And I'm just mentioning that because Mark, who is attending today, mentioned that they're a Linux user. So I just wanted to say, so am I. I'm presenting to you on an Apple Mac because I have a Windows machine and I didn't like it. So I'm glad we're not recording. Anyway, so database administration through the ages. What does it mean to be a DBA in 2023? This is my slide. Everybody has one. It is a picture of me, which is, I think, older than the one that is on the title card. But if you look carefully, those glasses don't even have lenses in them because I'm a goof. I'm an actor and author, activist. I like C#, I like SQL Server, and I really like chocolate. My pronouns are they and them. And if you want to get hold of me to discuss anything you've mentioned or we've mentioned today, you can email me at randolph.ca. The A is an @ And on the right here are some books that I've co-written. I have never finished a book on my own. I've always had to rely on the kindness of strangers, and that goes for people that I currently work with as well, which is pretty awesome. I work for Microsoft, as I've mentioned, but I also moonlight on bornsql.ca. That used to be my consulting company, and now it's just my blog. So if you want to go have a look there, please feel free. All righty. What does a database administrator do? Before we go on, I just wanted to say, if you have any questions, please let Deborah know or ask your question in the chat, and then you can interrupt me and ask the question. Or we can leave the questions to the end. That's your choice. If you do interrupt me, I will be able to bring it back on track if we start going off in a tangent. So the first thing I'm going to say is, what does a database administrator do? Well, this is such a loaded term these days. What is a database administrator anyway? Is it somebody who sits in a corner and plays with SQL Server and runs scripts and says no to people a lot? Or should we expand the definition a little? And I thought about this and I decided that we are all actually data professionals. It's a less exclusionary title. We work with data. We are professionals who work with data, and that now becomes a little bit more inclusive as well. We now deal with folks who know Microsoft Access. We deal with folks who do Power BI. We deal with folks who do Excel. We are data professionals. The fact that a lot of us use Microsoft SQL Server and associated Azure SQL products shouldn't be exclusionary. So we're data professionals. We deal a lot with data, and that's the gist of what we're going to be discussing today. So because I'm a hack, I stole this list from Wikipedia, and this is going to basically outline what a database administrator or a data professional does these days. You install, you upgrade, you migrate, you configure, you plan, you resource capacity management, you modify data structures, you manage data security, user security, and compliance. I'm not going to let you read that because you know all of this. You also manage high availability, you manage disaster recovery, you do queries for reporting and analysis, you monitor the data estate, and you deal with customers, internal and external. One of my favorite things to do now in my new job is deal with customers. And I say favorite and I mean it. I'm not just being facetious, because one of the great things about coming from a support background, which I do, is learning new things that people are doing with products that either you've built or you've worked with most of your life. And sometimes you learn things that you never would have expected if you're just willing to listen to customers. Yes, customers can get angry and they can yell at you, but if you listen to what they're trying to say instead of how they're saying it, usually you can learn a lot from almost every interaction you have with a customer. So let's talk about what data professionals know. Now we've said this is what you do: you install, you upgrade, you plan, but you also need to understand things like database theory and design. So how do tables work? How do indexes work? How do functions work? Why you should never use triggers? That was a loaded statement. Database queries, how to write a select statement, how to write a update statement, how to write a where clause. And you also should have not necessarily a deep understanding of internals, but a basic understanding. So you know what a data page is, that it's 8 kilobytes, and therefore you can't have certain fields that are longer than 8,000 bytes. And you need to know that there's a page header and that the indexes and the tables are stored in certain ways. That kind of stuff will go a great way to helping you write good, efficient queries so that you can continue working in this new Azure and AWS and Google, I've forgotten what they're called, cloud technologies. It's all the same stuff when you get down to the end of it. You need to know your SQL, your structured query language. You need to understand, if not know in depth, how distributed computing works. So you have a server somewhere and you have a client somewhere. You may have an application server, you may have a database server. You may deploy these on Kubernetes pods, or you may just have a server in a broom closet somewhere. You need to understand these concepts so that when something goes wrong, no matter what the technology stack is, you have an inkling of what you need to look for. You need to understand that operating systems exist like Windows, Linux, and Mac OS. How they're different is one thing, but in most cases, they're very similar. Windows, Mac OS, and Linux are very similar. How you interface with them might be slightly different, but they all have the same principles behind them. You need to understand storage technologies and networking. Now, I've put and networking at the end here, but honestly, networking is probably the big thing that if you don't know now, you should learn. And I'm saying that as a school teacher because I used to be a school teacher, but networking is going to be the thing that defines how you approach cloud technologies, because the network is going to be the problem most of the time. So I cannot see you, and not all of you are on camera, and I'm only using one screen. So I'd like all of you to answer in the chat, which versions of SQL Server have you used? I'll give you about 30 seconds to answer the question. You can say you started in 6.5 and you know every version, or you can say you just started recently with managed instance. Just answer the questions in the chat, and Deborah can read them out in a few seconds. And then I'm just going to look intently at the camera and intimidate you while you do that.
We've got a 7, frankly, none before joining Microsoft. Got more bubbles going here. 6.5, 7.0, 2000, 2005, 2008, 2008 R2, and 2012.
That's great. So in most cases, people will reference something on this list, usually starting around 2000 and onwards, but some folks have said 6.5. I started using version 6.5 because I worked with a PeopleSoft consulting company back in South Africa before Oracle bought them. In case you're wondering where my accent comes from, it's Johannesburg, South Africa with a Canadian accent. And so 6.5 is where a lot of folks started. Of course, there's a whole bunch of new stuff nowadays. You've got Azure SQL Edge, SQL Database, SQL Managed Instance, Containers, Kubernetes, and BDC. For $5 and good luck, what does BDC stand for? It doesn't matter what it stands for because it's no longer supported. Sorry, folks. So sadly, BDC was a very, very good idea. It was about distributed computing, and unfortunately, not enough people were using it. And so Microsoft is no longer supporting it in any new versions. And I believe support ends for the existing version in 2025. So sorry if you were on that. These are the currently supported versions of SQL Server. We started with 2014 and we go all the way up to all the new fancy stuff. And that includes Windows and Linux versions as well as containers and Kubernetes versions. Yes, SQL Server 2012 is no longer in support. How many folks who answered the question are still using versions of SQL Server that are no longer in support? That's a good question. Anyone still using unsupported versions of SQL? Yeah. It doesn't matter though, because it's all just SQL Server. Since version 7, which is the one where Microsoft rewrote the database engine and changed the size of data pages to 8 kilobytes, it's been pretty much the same internally. So if you have knowledge that relates back to 2005, 2008, 2008 R2, you're still in pretty good stead. There's been a lot of new advances since then, and of course, different multiple platforms that are available for the product, but it's fundamentally the same database engine that you know and love from back then. And Buck Woody, who is a Microsoft person as well, likes to say it's just SQL Server. It doesn't really matter how you're using it. So let's talk about what this actually means in real terms. There are 1 billion nanoseconds in 1 second. Okay, this is a bit of a segue from what we were just talking about, but this is important and I'll explain why. CPUs run in nanoseconds and humans run in seconds, minutes, hours, and days. So there's a fundamental disconnect between how we understand time and how computers understand time. And because of that disconnect, and because we don't understand this kind of stuff, it means that we don't comprehend how certain delays, slowdowns in processes can affect the operating of a data professional's environment. So here is a great slide. I love this slide. It's even better because I did it with Toronto and Calgary ping times. So on the left, we have a single CPU cycle of 0.4 nanoseconds. Then we have a level 1 cache call from the CPU to the level 1 cache, which takes 0.9 of a nanosecond. Then a level 2 cache is a little bit slower. It takes 2.8 nanoseconds. Level 3 is 10 times that. It takes 28. And dynamic RAM, DDR, is 100 nanoseconds. So you can see from the CPU to the RAM, it's slow. But this graph is meaningless because you cannot actually see any numbers here because of the ping times that we've got here and the hard drive stuff. So I'm going to remove the hard drive and ping times from this graph to try and show you a little bit more reasonably what CPU speed is relative to everything else. So here's an updated graph. We still have almost impossible to see up to 350 nanoseconds for an Optane PMEM access from the CPU to the PMEM and back again. It's 350 nanoseconds. So while all of this stuff is happening inside your computer, when you start getting to the solid state drive, when you start getting to NVMe, which is slower than Optane, and then when you start getting to SSDs, you can see that the ramp up of how long things take is exponential. And I think it was said best by Arnold Schwarzenegger in Terminator 2, it grows at a geometric rate. That doesn't mean anything, but I think it's a funny thing, and it's especially visible here, that how fast a CPU is compared to how slow accessing a hard drive is just on a different level. And so I bring to you, let's convert a CPU cycle into 1 second. That means that the level 2 cache access will take 2 seconds. That means DDRM access will take 4 minutes. That means NVMe takes 17 hours, SSD takes 3 days. A single millisecond for a LAN ping, so on hard cable, will take 1 month. Wi-Fi will take 2 months. And if you want to send traffic from me to you, in fact, this very conversation we're having right now has a 41 millisecond ping time. It would take 41 months, almost 3.5 years, for you to send information to me, and if we were using the CPU clock cycle as 1 second. So I want to spend a few more seconds you looking at this chart to understand why network matters, why it matters that you have a fast network connection, why your queries have to be efficient, why you want to turn off no count on your queries when you're querying from SSMS, why you want to bring as little data over the network as you can, only bring back the things you need, because at scale, when you're talking about cloud applications, if your application queries are written badly, you're going to be waiting around a long time and spending a lot of money on compute when you don't need to, when you need to focus more on writing good queries. So I love this little graph to understand computer latency at a human scale. So let's talk a little bit about the CPU. What do we know about CPUs? Well, modern CPUs have multiple cores. That means that there are physically distinct processing units on the same die. A die is a piece of wafer, and then they've got physical CPUs sitting on the die, and then that whole die plugs into the motherboard. With CPUs and SQL Server, single-threaded performance matters more for online transaction processing. So for regular select, update, delete queries, OLTP queries, single-threaded performance matters more. So if you're looking to spec a CPU or you're looking to get a vCPU core on your virtual environment for SQL Server, you want to look for a CPU with fewer cores because that will give you higher performance. The fewer cores there are, the lower the heat. The lower the heat, the more it can do. And that means that you can get higher gigahertz performance out of those cores. One important thing to mention about CPU cores is that there are new maxstop options in SQL Server setup. Maxstop stands for maximum degree of parallelism. That means SQL Server can look at the number of cores that you have and say, well, I can actually parallelize some of these queries. Not all queries can be parallelized, but those that can will be shared across the CPU cores, which brings me to my next statement, which is about simultaneous multi-threading. This is the generic term for what you may know as hyperthreading. Hyperthreading is a trademark term by Intel, but it's what people mean when they say hyperthreading is simultaneous multi-threading. If you're looking from a SQL Server perspective, I cannot speak for other environments because I don't know them as well, but for SQL Server, if you get hyperthreading CPUs and you enable hyperthreading, you won't get double the performance. You'll get maybe 15% extra. So don't think of hyperthreading as free CPUs. Think of it as a little bit more headroom for some of those more expensive queries. 15%, not much more. And that's average. That's not for everybody. But if you're thinking of turning on hyperthreading, I would probably tell you not to. It may not be worthwhile, especially if you're going to virtualize using that CPU. Because if you turn on hyperthreading, your virtual environment may say, hang on, you've turned on hyperthreading, now you've got two CPUs. I'm going to use the second CPU, and then suddenly that VM just tanks in performance. So please be careful with hyperthreading, test everything, and just understand that hyperthreading doesn't mean double the performance, it means 15% extra. I'm going to pause here and say, are there any questions so far? Because I went from, hey, look how fast the ping time is, into talking about hyperthreading. So I know that it did go a little deep there. So if you have any questions, let me know. Please feel free to interrupt me. One more thing about CPUs is that AMD has caught up to Intel with their Ryzen CPU range. Now, this slide is a little old. I didn't decide to update it because I didn't mention that ARM has arrived on the scene and Apple Silicon is ridiculously fast, but they're not x86 platforms. So that's why I didn't mention ARM on this chip on the slide, but AMD and Intel for the x86 64 environments are pretty much on par. In the old days, you used to get a bit of a licensing discount if you used an AMD processor, but that is no longer the case. And in fact, some Ryzen CPUs are faster than their Intel equivalents. And then finally, speaking of CPUs, always make sure you disable power saving settings on a SQL Server production environment. This is the single way of making your SQL Server faster. If somebody says, hey, is there a turbo switch for SQL Server? This is it. Turn off power saving in your BIOS, turn off power saving in your operating system settings, and you will get SQL Server not having to ramp up the CPU when it wants to run a query. That is the single biggest tip I can give you for CPU configuration over and above the hyperthreading one that I mentioned before. So we're going to go from CPUs into memory now. I mentioned maximum degree of parallelism under the CPU. One, max server memory is another setting that you can configure in SQL Server that allows you to manage the RAM that you have available to you. I'm sure a lot of you know that SQL Server Standard Edition, depending on the version you're installing, has a limit of 128 gigabytes of RAM. Now that limit for max server memory is limited to what's in the buffer pool. So when SQL Server runs, it doesn't read data from the the disk and then run the query, what happens is the buffer pool, it asks the buffer pool, which is a space in memory for that data. If the data isn't in the buffer pool, then the buffer pool goes and asks for it from the disk, and then it brings it back in. But as far as the SQL Server database engine is concerned, the query engine, it's looking for information that is in the buffer pool. So the buffer pool itself on standard edition is limited to 128 gigabytes. That means you can fit 128 gigabytes, more or less, sometimes a little bit more, of memory, and then SQL Server's other stuff for standard edition goes on top of that. I'm mentioning this because standard edition seems to be quite popular in smaller companies that don't want to pay for enterprise edition. If you're using enterprise edition, the thing you have to worry about there is that you've got the right version for the number of cores that you're running, but for memory, you don't have to worry about that. SQL Server, if you're using enterprise edition or one of the cloud versions of SQL Server, it'll use whatever memory you give it. So if you've got 2 petabytes of RAM and you have SQL Server Enterprise Edition, it will use 2 petabytes of memory, up to 2.1 petabytes, in fact. How much is a petabyte? Well, a byte, 1,000 bytes is a kilobyte, 1,000 kilobytes is a megabyte, 1,000 megabytes is a gigabyte, 1,000 gigabytes is a terabyte, 1,000 terabytes is an exabyte, and 1,000 exabytes is a petabyte. 1,000 petabytes is a zettabyte, and there's one more, a yottabyte after that, which is just a ridiculous number. But a petabyte is a big number. So what that means is it'll use whatever memory you can give it. And that could be fine on Windows because Windows has a memory manager that is pretty okay with SQL Server using as much as it can. But on Linux, it can be problematic. On Linux, if you use too many resources, something called the OOM, or out of memory killer, will kill your process without asking questions. It'll just say, you've used too many resources, time to shut down, goodbye. Now, SQL Server on Linux has a special configuration that sets the maximum amount of physical memory available to SQL Server to 80%. That is a configurable setting. But if you want to increase that number to, say, 85 or 90%, be aware that the OOM killer could terminate your process without any warning. I skipped a little bit there to say that the max server memory setting does not apply to column store or in-memory objects, and that's because they need their own memory. So if you have, let's say, 256 gigabytes of memory, and you have Enterprise Edition, and you want to put some things into in-memory objects, and you want to put some things into column store, you may need to reduce your max server memory setting so that you have some headroom for those other things like column store and in-memory objects. And while we're on the topic of in-memory objects, please be advised that in-memory objects are not necessarily faster if you don't set it up correctly. And also, if you are going to put a 1 gigabyte table into an in-memory table, it will use 3 to 4 gigabytes of memory. So just keep that in mind. You may think that you're only using 1 gig, you use 4, and suddenly you have an out of memory condition and Windows blue screens, and SQL shuts down, or the Linux OOM killer comes and terminates your process. So with memory, you must configure max server memory. I don't know what your settings should be. Only you know what your settings should be, but you must set this value so that it is reasonable in your environment. The good news is on SQL Server Setup, on Windows, you will have an option for it to detect how much memory you have at install time. So if you do have a VM that you move to a different host, or if you're using scalable stuff, you will need to keep this in mind. But when you install SQL Server the first time, it will tell you, I've detected this much memory. I would recommend this much as your max server memory. Please take that setting into account because you do need that extra headroom for other things. This is my favorite fact about memory. Did you know that something that happened 1 billion years ago could flip the data in memory on your computer if you have more than 32 gigabytes? Yes, this is an interesting fact that I learned. Because of the density of memory, so the density of the chips on a stick of memory and how close they are together, at about 32 gigabytes, a cosmic ray from a gamma radiation burst from a star that happened 1 billion years ago could change the bit in that memory module from a 1 to a 0 or from a 0 to a 1. Isn't that amazing? I think that's amazing. And so because of that, you need to use ECC RAM. ECC stands for error correcting. I never remember what the third C is. ECC RAM costs a little bit more money, but it is absolutely worth it if you're going to put more than 32 gigs of RAM into any machine, whether it be your desktop device or whatever. ECC RAM, do it, kids. And then finally, this is one of those things that is a contentious issue when it comes to configuring memory, this is only available on Windows, but there's what is the correct terminology? Because I always get into trouble if I say this wrong. This is a policy. This is a Windows policy called lock pages in memory. It is not a configuration option in SQL Server. It is a policy. What it does is it says once this memory has been allocated to SQL Server, it belongs to SQL Server. So nothing else can take it until SQL Server says I don't need it anymore, which is usually when it shuts down. So if you are going to turn this setting on, don't turn it on with a virtual machine that is on a shared host because it will blue screen, basically. Don't do it. If you're going to use lock pages in memory, it should be on a dedicated instance or a dedicated virtual machine on its own host. So I'm going to pause here again and ask, are there any questions about CPU or memory? And you can come off mute if you don't want to type in the chat as well. If not, I will continue. I hope you're all there. All right, let's talk about storage. Persisted storage. I'm being very specific there because persisted storage means a certain thing, whereas storage on its own could mean multiple things, and I'll explain why later. Persisted storage, or what you might consider as a hard drive or solid state drive or NVMe, that kind of thing, is when you turn the computer off, it's still going to be there when you turn it back on again. That's what persisted storage means. Persisted storage could be some file share on the network, or it could be a Azure Blob storage container in the cloud, or it could be an external USB hard drive. Please don't do that on your SQL Server server. So persistent storage, the rule is faster is better. Solid state eliminates seek times. So on the old spinning hard drives, you had the disk that spun, and then you had the read head that read over the top of the surface of the disk. It never touches the disk, but it reads over the top using magnetic fields. So what happens is the disk spins, and then the read head has to say no, no, no. Okay, there it is. That seek time is eliminated with solid state storage. So a cell, an addressable cell where data is stored on a solid state device has an address. And so the CPU through the hard drive controller knows what that address is in advance, and it can go directly to it. It doesn't have to wait for that seek time. So solid state eliminates seek times that spinning drives have. If you're deciding to buy a new SAN or a new, what do they call them? Attached storage or pure storage, that kind of device, you need to test the IOPS. IOPS stands for input and outputs per second. Inputs and outputs per second. There's I forgot the name of the tool now. It's not SQL Hammer, but there's a tool that you can use for testing IOPS on any environment. So when you set up SQL Server for the first time, test the IOPS with a large block size. That means a 1 megabyte or a 2 megabyte or a 4 megabyte block size. That's because SQL Server uses 64 kilobyte extents. When I spoke about 8 kilobyte pages back earlier in this chat, I mentioned that each data page is 8 kilobytes in size. It tends to read and write them 8 at a time. So 8 times 8 is 64 kilobytes. So if you're going to be testing the IOPS of your storage, you need to make sure that you're testing extents bigger than 4K, which is what some of these IOPS tools will test. IOSIM, I think it's called. SQL IOSIM is the name of the tool, at least for Linux anyway. The thing about solid state drives and hard drives for that matter is something called a queue depth. When you are testing IOPS, let's say that your drive performs really admirably where it can do tens of thousands of IOPS and that's great, and everybody's happy. And then suddenly you start putting load through your server, and then it just slows down to a crawl. That's because there's something called the drive queue depth. So there's a queue of instructions for that storage layer that are backing up. And your drive queue depth, if that starts building up, it'll slow everything down. So when you are specifying new hardware for your storage, you need to care about IOPS with a large block size, and also make sure that it has a good drive queue depth. I hope that makes sense. And finally, this is my favorite fact about on this slide, malware detection is the enemy. There is a very well-read KB article on a Microsoft support website for how to configure your antivirus. I would encourage you to go and read that, and also a little bit of insider information. I and one of the senior escalation engineers inside Microsoft are going to be rewriting that article in the next few months to be more up to date, more relevant to newer versions of SQL, because that article is a little stale right now. But what you need to understand is that an antivirus product will install something at the file system level. Now, SQL Server works below the file system level. It works on blocks. So it bypasses some of the, it bypasses a lot of the things. And unfortunately, the malware detection algorithms will see that as antivirus, or sorry, as malware behavior. So it has to read all of the drive accesses. So you have to exclude SQL Server from your malware detection. So if you're using Microsoft Defender, which is built into Windows, or you're using any of the competitor products, please make sure that you exclude SQL Server's backup files, MDF, NDF, LDF, trace files. If you're using trace, please don't use trace. But if you are, you need to exclude those as well. You need to exclude reporting services. You need to exclude the SQL Server process. There's a lot of stuff to go through. You should check that out immediately. If you're having a slow server on brand new hardware, check your antivirus settings. Let's talk a little bit about the newer stuff. I say newer because this is hyperconverged, has been around for a while. But hyperconverged is a HCI infrastructure. Well, HCI means infrastructure, sorry. You have a bunch of CPUs and a bunch of storage and a bunch of RAM in different nodes, and they can do all sorts of cool things, and everybody's happy until suddenly the performance tanks when SQL Server gets busy and people go, well, you know, we spend all this money, these millions of dollars on this HCI, and now everything's slow. And the reason is because storage in the hyperconverged infrastructure also needs CPU. So when you set up your HCI, you need to make sure that the storage layer that you're accessing has its own dedicated CPU, and that you don't try and share that with SQL Server. That's very important for on-premises environments. And finally, talking about storage, there's something called PMEM, or persistent memory, that is available on both Windows and Linux. I believe it was introduced in Windows Server 2019 and Linux around the same time. And persistent memory is basically an SSD card on the same physical RAM chips that you have. So on one side of the RAM, you've got actual random access memory, and on the other side, you've got solid state. So what that means is anything that's inside the RAM, if power leaves the server, so something happens and there's no more power, whatever is in RAM will be written to the SSD. That's one thing. Then you've also got a backup battery for that device, right? Because if you lose power to the machine, then obviously it still needs to have some way to write that to the solid state storage that is on the RAM. The cool thing about persistent memory with SQL Server is that if it sees it as a hard drive, it's going to use it as a hard drive. So it's going to go to the buffer pool. The buffer pool is going to say the data page isn't here. I need to go to the storage layer. So it goes through the storage layer drivers. It goes all the way back up again. And remember, we spoke about this in the beginning, a CPU 0.4 nanoseconds versus the 1,000 nanoseconds for whatever the cheapest storage was, or 100, whatever it was much slower. That gets bypassed if you use the hybrid buffer pool. So what that means is it knows that it can use this persistent memory instead of using the storage layer. So it bypasses all of that and it uses internal memory operations to go directly to those to that persistent memory. So it's a very cool feature if you can afford it. Okay, before I get into network, are there any questions? Are you still there?
We're still here.
Oh yeah, yeah. You're here. A lot of learning, really.
I said this at the beginning, that the network is your enemy when it comes to cloud. And it's also the case when it comes to even on-premises stuff. Latency is the enemy. When you're dealing with any sort of data access with SQL Server and you want to get your results quickly, your application and your data layer need to be as close together as possible. And you should aim for less than 10 milliseconds access time. When I was a consultant and I would go on premises and help people configure things, I would say, excuse me, your temp DB, which has to be on the fastest storage you have available to you, your temp DB and your transaction logs should have an access time of less than 2 milliseconds. Now you're thinking to yourself, 2 milliseconds, that's so quick. How am I supposed to do that? But the CPU is operating in nanoseconds. There are 1,000 microseconds in a nanosecond. There are 1,000 microseconds in a millisecond. There are 1,000 milliseconds in a second. So all of these things add up. You want to have your access times for your storage layer to be as fast as possible. So for transaction logs and for tempdb, less than 2 milliseconds. For your data files, less than 10 milliseconds. That is your target. Now, I understand not everybody is able to do that, especially if you are working in a server that's been in your broom closet. But that's the target. That's what you want to go for, because otherwise SQL Server waits. And if SQL Server has to wait around, then the wait statistics start growing. And then everybody panics because now, oh, look at these wait statistics. And oh, SQL Server is terrible. No, SQL Server is not the problem. Your network is the problem. So this is something that you have to aim for when you're setting up your storage layer and also when you're setting up your network environment and your application layer. Now I've put here as a joke, it was DNS, says everybody, basically. DNS or domain name system is the way that we convert IP addresses into domain names, which seems obvious because that's how the internet works, except it also affects your internal network if a SQL Server goes down and it was called SQL01.mycompany.net and suddenly SQL01 is no longer available. Now you have to update all your connection strings to something else. And if you're updating connection strings and you're using weird CNAMEs, that TTL or time to live entry, which maybe you set to 8 hours because why not? Now you have to wait 8 hours for all of your applications to update their connection strings. Nobody wants that. So your time to live, your TTL, when you set up a CNAME or a DNS entry in your internal network, you want to keep that as low as possible. Not 5 seconds, but let's say about 5 minutes. That means if you have a failover and you need to rename your connection strings, and we'll talk about connection strings a little later, but if you need to do that kind of thing, at least if your TTL is low, like say 5 minutes, then you can be able to test your new connection strings within 5 minutes after the failover happens. Otherwise, you're waiting for hours and sometimes the entire weekend, and good luck to you. So what I was going to say about connection strings is that oftentimes you don't want to even worry about that. What you want is something called a virtual network endpoint, or that's how availability groups and previous to that clustering worked. So you give a virtual IP address to multiple servers. And if one goes down, the virtual IP still manages to figure out where it should go. So yeah, please, if you're setting up a local network, DNS is going to hurt you whether you like it or not. It's just going to happen. I promise you. This is my promise to you. Never shrink a SQL Server database automatically, and never think that DNS will never hurt you. DNS will always hurt you. So those are the 2 rules of SQL Server. So please, when you set up DNS, make sure that your TTL is set to a reasonable time of 5 minutes, not 8 hours, which is, I think, the default. I've got a little at the bottom left here, a little thanks to Jeff Moden, who is and he won't mind me saying this, a crusty old white guy who came up with the term row by agonizing row, or rebar. You may have heard this in a bunch of presentations if you've been around the SQL Server community for a while. What that means is you don't want to ask for one row and then the next row and then the next row. SQL Server is a relational database management system that returns data in sets. A set is a bunch of data at one time. You want SQL Server to give you the information that you need in one go as efficiently as it can. So you don't want to do row by agonizing row. That's what rebar means. So you want your set-based operations. You want to make sure that no count is on, because guess what? Guess what? If you don't turn no count on, and no count is a setting inside Management Studio, and you can set it when you set up your environment to create a connection to SQL Server. If you're typing along there in SQL Server Management Studio or Azure Data Studio or SQL CMD or Go SQL CMD or whatever it is that you're using this week, and you type select star from whatever, and then you press enter, and it says 28,000 rows returned. Well, guess what? After that 28,000 rows were returned, it went back to the server and said, hey, how many rows were returned? And the server says, oh, it was 28,000. It says, okay, cool. So it sends back the information. Then it sends back a reply saying, okay, got it, thanks. And then it sends it back to you. So every time you do something on SQL Server and you don't turn on the no count option, it's going to send extra network traffic that you're not even aware of. So by virtue of turning on no count, you could potentially double the performance of some of your smaller queries, because it doesn't need to do that trip back to the server to say how many rows were affected, because you don't need that information sometimes. And if you're doing it in your application layer, your application knows how many rows it got back because it has them in memory. So you don't need that kind of information. So something else to think about. And don't use Profiler. I made a dig about trace files earlier. Profiler, which is a product that Microsoft released for figuring out what's going on inside a SQL Server environment. It's great. It's a great tool for troubleshooting problems in a development environment or a test environment. But if you use it on a production environment and you've got a lot of traffic going through your system, how do I put this nicely, being an employee of Microsoft? When something happens on SQL Server, it says, okay, I've done this thing. And then Profiler says, thank you, got it. And then SQL Server says, okay, now I've done this thing. And Profiler says, okay, thanks. And then SQL Server says, I've done this thing. And Profiler says, okay, cool. And so every time something happens on SQL Server, there's that network traffic happening again and again and again, like I've just mentioned with the no count story. And the problem is that even if you're running Profiler on the same hardware, the same machine as SQL Server, it's still generating that extra overhead. So you can have, this is not an exaggeration, you can have up to a 15% performance degradation just by looking at it. In other words, if you've got Profiler running, you can have up to a 15% degradation in performance just by having it running. So if you're going to use Profiler, please make sure that you do it in a dev environment, that you use trace files instead of running Profiler actively. Because if you don't do those things, then you could slow SQL Server down. And when I say don't use Profiler, there's something better. There's something called extended events. I mentioned to you that SQL Server says, okay, Profiler, I've done the thing. And Profiler says, thank you. With extended events, SQL Server writes to what's called, well, I've just forgotten what it's called, it just went out of my head, but it writes to the ring buffer, that's what it's called. So it writes to a piece of memory that just loops. And the extended event client can look inside there and see, okay, these things are happening. And if the extended event client isn't fast enough, it might miss some things, which is okay. It really is okay. But what SQL Server is doing is it's sending information out, and whoever's there to receive it can get it. Extended events can slow SQL Server down as well. There are some extended events that can cause it to slow down a lot, but not all of them. And so you're looking at an overhead of between 3 to 5% using extended events versus using Profiler, which can be as much as 15%. So please don't use Profiler on a production environment. And everything in the cloud is defined by the network. I'm talking to you on a MacBook Pro, which is using my Wi-Fi connection. So I've already got a 22 millisecond ping time from here to my my network endpoint over there, which is hardwired. Then it goes all the way to you in Toronto, which is a 41 millisecond delay, and then it comes back, and then it comes back. So every time I say something to you, it sends it over the wire, and it takes time. So please make sure that whenever you're doing something on the network, that you are cognizant of doing it in the most efficient way. Set-based operations, small queries. Don't do a sort on the server. You're spending thousands of dollars on a license. If you've got an application that can do sorting in memory, do that instead so that SQL Server can be released to do other things that are more important than ordering by last name. So let's talk a little bit, unless there are questions, let's talk a little bit about what I call virtual consumers. I came up with this term, and what I mean is virtual machines and containers. I classify them under this term because they're kind of sort of the same thing, even though they're not. That's why I called it an abstraction onion. A virtual machine abstracts away the hardware layer. So instead of having a physical CPU, physical memory, physical storage, you have virtual CPU, virtual memory, virtual storage. We've already mentioned virtual CPUs. Watch out with hyperthreading, which is called symmetric multiprocessing. Docker is the company you may have heard of when it comes to containers, but you also would have heard of Kubernetes. You also would have heard of OpenShift. You would have heard of some of the AWS stuff, Amazon Web Services, AWS, if you don't know. And Google's got their own thing as well for working with containers. So while Docker did come up with the idea of containers, they have formed something called the OCI, the Open Container Something, which is a standard specification body about how containers should work. Now, somebody on this very call has written a whole very interesting series of little bite-sized comics, if you like, of how containers work, which I would recommend. Mahalo, who's on the call, bite-sized engineering. I think that's the name of the comics that you've done, which talks about how containers work, and it's a very cool way of understanding the basics of how this sort of thing works. A virtual machine thinks that it's running on physical hardware. A container thinks it's the only thing running on that machine. So the container doesn't care about operating system, it doesn't care about other things, but it thinks it's the only thing running. So you can partition your machine to run multiple containers using fewer resources than a virtual machine, because the container doesn't care about the hardware. It just thinks it's the only thing there. So that's kind of the abstraction onion that I'm talking about here. Windows implements containers slightly differently to the way that Windows implements containers to how Linux can do it. Linux can have the containers without any sort of virtualization layer. It's just a little partitioning thing that it does, whereas Windows might have to, you might have to use Hyper-V or whatever the case may be. So each one has its own implementation details, but the important thing is containers use fewer resources than VMs and therefore are easier to configure. Now, the problem with containers is the same problem you have with rabbits. You'll have 2 rabbits today, and next week you'll have 200,000 containers. So please, when you're using containers, keep in mind that it's very easy to get carried away. If you're using containers because they're cool, you're doing it wrong. If you're using containers because it's helping you produce a containerized development environment for your employees, then you're doing it right. I've said that VMware and Docker are the market leaders on the slide, but Hyper-V isn't going away anywhere, and there are other ways of doing containers. So you should, it's part of networking really, you should get involved in containers and understanding how they work. If you're going to manage multiple groups of containers, you need to use Kubernetes. And here's my favorite fact about Kubernetes. The K stands for the K at the beginning, the S stands for the S at the end, and there's 8 letters in between. That's what K8S stands for. You're welcome. Kubernetes is how you manage containers. I've mentioned OpenShift, which is Red Hat's one. AKS, which is Azure Kubernetes Service, is Microsoft's one in the cloud. There are multiple ways to do container management. Kubernetes is basically your management framework for operating these different containers. If you have Linux knowledge, like one of the attendees today and myself, it will really help you because they originated there. So there's some of the, well, I won't say some, I'll say most containers run on Linux, or the containers think they're running on Linux. And so if you have Linux knowledge, that will help you a great deal when you're troubleshooting something, or you have to connect into the container and figure something out. I've said their Windows containers exist. That's all I'm going to say about that. Now we're heading into the home stretch now. We're perfectly on time, but I will pause for questions if you have any. Cool. Remember that broom closet. So what it really means to manage your data estate in 2023. The reason I added this slide is because my colleague, Sydney, who works on the database docs team, said something very funny earlier today about, we were talking about networking. I just want to see if I can find the quote. The cloud makes bad apps worse. If you build a solution that's not resilient or responsive, it gets exponentially worse on distributed commodity hardware. Some organizations are surviving solely because the server running in their broom closet was a bit overspec'd, which I love. So in other words, some people are just lucky because they happen to be running locally. If they had to lift and shift their code to the cloud, it would be horrible because the network would be horrible. So something to keep in mind. Those broom closet engineers, I am one of them. I used to run several companies who had their servers in a broom closet. Yeah, those can be interesting environments to work in, and they're very different to how the cloud operates. So how do you manage your data estate in 2023? Well, you've got to have tools. SQL Server Management Studio is the one that most people are familiar with, and it has a cute little icon, and version 16 of SSMS, which was decoupled from SQL Server after 2014. So now SSMS has its own release cycle, and SQL Server has its own release cycle. The 64-bit version of SSMS is coming. Aaron Stellato, who is on the Microsoft team, who's leading the tools team, said that I could tell you that. So there is a 64-bit version of SSMS coming, which means that you won't run into a lot of the performance issues that SSMS currently has, which is memory errors and performance and not being able to open a lot of tabs and that kind of stuff. And the reason I can tell you this is because Visual Studio, on which SSMS is based, has become 64-bit. So if you used Visual Studio 2019 or 2022, you'll know that that's a 64-bit environment, so SSMS is going to adopt that. Then, Azure Data Studio. I have to mention Azure Data Studio, and not just as a line item. Azure Data Studio is a cross-platform product, which is based off the old, it's the same code base as Visual Studio Code. I say it's the same code base, but it's been extended. It's not just I've installed VS Code and here's a bunch of extensions that I've added. It is designed for data professionals. So you can do stuff like manage your SQL Server environment. You can run queries. You can do a whole bunch of stuff with ADS, and it runs almost everywhere. So if you do have a Mac like I do, or you have a Linux environment, you can install Azure Data Studio and interact with a SQL Server environment as if it was running on Windows. Now, SSMS and ADS are never going to combine, but there are going to be some things that ADS does better than SSMS and vice versa. But ADS is being improved every month. Every month there is an update for Azure Data Studio, and the features that it has, if you haven't looked recently, go have a look. I think the latest version was 1.4.2, excuse me. There's a bunch of cool features in there that you should definitely look at. Then from the command line, SQL CMD is a stalwart. It used to be called something else. I forget what it used to be called in SQL 2000 and before. But SQL CMD has been there forever. And in fact, because it's been there forever, one of the risks that happens is that you've got to keep this product going for hundreds of years. And so Microsoft said, well, you know what? We're going to create a new version of SQL CMD, which they did. It's called Go SQL CMD. And Go SQL CMD, which has exactly the same feature set as SQL CMD, so you can use it in place, will allow you to set up a container with SQL Server running in it and create a database for you with one command. Isn't that cool? Go SQL CMD. Look it up. It is amazing. Then there is MS SQL CLI, which hasn't had a lot of attention since it first came out, but I like to mention it because it has things like IntelliSense and autocomplete and stuff like that. MS SQL CLI, pretty cool, but it hasn't been looked at for a while. And then, of course, there's BCP. BCP is the fastest way to get data in and out of SQL Server from the command line. The fastest. There is nothing faster than BCP. Yes, it's a little arcane with the format files and so forth, but it does support JSON. It does support, let me rephrase. It does support importing of certain formats. It supports CSV. I don't want to promise JSON because I don't actually remember. But BCP is the fastest way of getting data in and out of SQL Server, and it is also cross-platform. Very cool to know these things, because when you come onto a site and you're a consultant and you cannot install ADS, you cannot install SSMS, BCP is there, SQL CMD is there. They're very useful tools to get to understand. And then let's talk a little bit about the other things that are out there. PowerShell also is a cross-platform environment where you can use it on Windows, Linux, and Mac OS. You've got your SQL Server module, and I've put in brackets there SQL PS, which came with, I want to say it was 2005 or 2008, whenever PowerShell came out the first time. That PowerShell module is obsolete, but the SQL Server module is constantly updated. And I think there was an update a week ago or 2 weeks ago for that. DBA Tools is a third-party administration environment using PowerShell, written by the community, and that's the link, dbatools.io. I know Chrissy Lemaire, who founded the project, and I know a lot of the people who work on that project, and they are I think there's 700 or 800 commandlets that you can do with DBA Tools. You can take, I'm not kidding, you can take DBA Tools and say, point it at that SQL Server 2000 server over there, and point it at the SQL Server 2022 server over there and say, hey, I want you to migrate all of my databases from that server to that server, and you can do it with one command. DBA Tools is amazing. You can set up availability groups with one command. You can set up failover clustering with one command. DBA Tools is amazing. Check it out. I'm not just saying that, it really is good. And then something that I added to the slide now, if you're using Azure in the cloud, there are AZ PowerShell commandlets as well that allow you to do pretty much the same stuff that you can do with the SQL Server module. So although the way of thinking with Azure SQL Database is slightly different because you're at the database level instead of the instance level, you can still get a lot of the same things done, and the commands are almost identical. So definitely look at AZ PowerShell commandlets, and there's also the AZ CLI, which you can use. So it's a command line interface that you can use in the portal itself, or you can use it from your local machine. And again, those are all cross-platform. And then finally, SQL Server Management Objects, which is SMO, which you may have heard of before, is open source. So you can go and go to the GitHub repo and have a look at how server management objects work. It's great. SMO is very, very cool. And so is the query parser. What I mean is it's also open source. So if you want to incorporate, which is what I'm doing at work, in fact, I'm using the open source SMO thing to make sure that the code examples that we have in our SQL docs are correct or valid SQL. And that hasn't been finished yet, but that's something that I'm using. I'm using the open source library so that I can parse the stuff that we're using internally. I think that's pretty cool. So let's go into questions if you have any, because that's my time. And I hope you learned some things. The thing that I want you to learn is that it's just SQL Server. You have a CPU, you have memory, you have storage, and you have the network. And those 4 things are more important than whatever the flavor of the week is, which is changing every day. Like even OpenAI uses CPU, memory, storage, and network. It's all there. Questions? I'm going to stop sharing and maybe we can just have a little conversation. If you still want to get hold of me, my email address is there again. You can read my blog on bornsql.ca/blog, and I hang out most of the time on learn.microsoft.com/SQL. So I'll leave that up for a couple more seconds if you want to screenshot that. Otherwise, I'm just going to stop sharing and we can have a chat. Here we go.
Hey, Donald, thank you so much. My role has been changed in the meantime. I'm purely into data engineering side, but two things to take away from here today. One is, I used to use this set no count off. I didn't know actually why I was using it. It was like this. First, I learned that this is the word. And other one you mentioned, I'm still using Azure SQL Studio or Azure, Azure SQL. It means we say like all this order by, right? All of things not to
Yes.
use it. So cost saving. So those are like
Yeah.
key takeaway from today.
I'm glad you got something out of it. I appreciate that. Does anybody have any other thoughts or comments that you'd like to share? And it's okay if you don't. I really don't mind.
Thank you, Rand. It was a wonderful session. It's like reliving what we have come through the production issues and everything. Mainly when you touch the point of having the antivirus could jeopardize the performance. That's something we had in and out when an organization went into cyber attack situations. So really thought provoking session. Thank you so much.
Thank you. I appreciate that. That's very kind of you to say.
Yes, thank you so much. There was a lot of it that I didn't understand because I'm kind of newer to this. So I'm like, whoa, this is a lot of words and things. So very knowledgeable. You're very, very knowledgeable.
I'm going to plug my book, of course, and I'm going to say buy the book. But on a more serious note, without plugging the book, there is a lot of content on online, YouTube, even learn.microsoft.com. I'm going to have to mention that because I work there, but there's a lot of free content available for you to learn more about these things. There's a lot of folks out there who are selling training as well, but there's just so much to know. You cannot know everything, Deborah. There's stuff about Power BI that I will never know, that you can just say, oh yeah, you just have to do this and this and this, and I'm going, don't get it. So yeah, don't. Can you hear me? Because I unplugged.
Yeah. Oh, you're cut out again. There you go. You're good.
I unplugged my microphone. So don't feel bad if you think there was a lot of stuff to cover, because at the very least, if there's stuff that you want to learn more about, then now you've got the framework to say, well, I want to learn more about CPUs, or I want to learn a little bit more about storage and stuff like that, and then go and learn that thing. I happen to have a very shallow amount of knowledge about a lot of things because I had to work in different environments. That's why I called myself a broom closet technician, because like, you have to know everything. You absolutely have to know everything to keep the thing going. But there are some folks who are specialists in a very specific area, and that's also a perfectly valid way to go. So don't feel like you have to know everything. I don't know everything.
Okay, good. Thank you.
All good. Well, that's all I had. If you want to get hold of me, as I mentioned, I shared my email address. I'll just mention that you saw me present so that I don't put you into the spam folder, and we can continue this conversation. I'm not on Twitter anymore. I decided yesterday of all days to stop being on Twitter. I'm not there anymore. I think it's we're still recording. It's not a nice place to be. So